Check. Yeah. Good afternoon, everyone. And first of all, thanks a lot for making it here to Houston for TechEd. Andrew Edwards out here, and I'll be presenting Azure Storage today. We're going to begin with a quick introduction. This is going to just cover some basics of what Azure Storage is, how you can use it, in what scenarios you can use it to reduce your own COGS as such, your operational costs. In addition, we will just go through the various abstractions that we provide in Azure Storage for your consumption. We will then cover what's new. There are a lot of things that we have announced today, and Andy will be covering a lot of these scenarios again and new abstraction that we have. He's going to cover more on that, and then what's coming in terms of in the next few months. And then we'll end off with patterns for scalable and resilient applications that you could use to kind of scale your own applications as such. So what's cloud storage? It is a storage in the cloud that provides you anywhere, anytime access. The caveat being as long as you have internet connection, obviously. It provides you blobs, tables, dis and queues as abstractions, and Andy will be adding a new abstraction towards the end of the talk. It's highly durable, available, and massively scalable system. It's durable because we retain multiple copies of your data. So when you send us a request, we actually make it persistent on multiple nodes and then return success to you. It's highly available because of the way these copies are maintained within our data centers. And it's massively scalable because we use range-based partitioning scheme. So we understand your traffic pattern that comes to us, and with that, we auto-load balance these partitions so that we can meet your traffic needs. All this allows you to build internet-level scale applications very so easily on top of Azure Storage. And the proof being that we do more than 25 trillion, we have more than 25 trillion stored objects, and we do more than 2.5 million requests per second on an average in Azure Storage. What's cool about this is it's pay for what you use. So there's no upfront cost of planning saying you need to store 300 terabytes of data over the next 2 years, so I need to plan for my data center or anything of that sort, or maybe even petabytes of data. It's pay for what you use. So as you grow slowly, that's how you would be charged. It's exposed via easy-to-use REST interfaces, so there are REST APIs. And for those who are used to using client libraries, we have client libraries in various languages. Cloud is truly language agnostic, so we have a lot of languages like C++, Java, Android, .NET, Node.js. So quite a few libraries out there which you can start using. In addition, there are value-add tools like which enables you to copy your data from on-prem to storage and vice versa. And so all these things is what Azure Storage kind of exposes to help you build internet-scale cloud applications very easily. In terms of regions, we have 16 regions worldwide. So this year, 2014, we'll have 16 regions. By far, it is the most number of regions that any major cloud provider has. So this is something which, again, enables you to build your cloud storage applications based on where your consumers are. Double-clicking into the abstractions that we spoke about, blobs provide you a massively scalable object store, basically for your unstructured data as such. So you can store your files or what you have on your on-prem logs and things like that into the cloud. It provides you a simple REST interface for putting, getting, deleting blobs, listing your blobs, and things like that. In terms of scenarios that it helps you build, there's data sharing scenarios where you can share documents either with everyone, making your container public, or with a subset of folks by using authentication modes like shared access signature. In addition, you have the big data scenario. All of us have tremendous amount of logs that we have for our own applications. That's true for any application. All these logs can now be analyzed in the cloud by keeping it in storage and then using whatever your favorite MapReduce job is to go and analyze these logs and get important data out of these logs to improve your service or your application. Backups is another common scenario where many people have written backups to the cloud. So they back up your phones or your important data, on-prem data, into the cloud so that you can retrieve it anytime you've lost a device. In addition, people have built sync services. So you want to back up from one, maybe back up your images and make it available on another device. So all these scenarios are possible through blobs. These are network-mounted VHDs in the cloud. And these are basically stored as what we call as page blobs in our Azure Storage Blob Azure Storage Blob abstraction. They are fixed format VHDs, and in the cloud, in any one of those virtual machines, now you can go and attach this blob as a VHD. So you get a disk where now your on-prem applications that were used to writing to a disk can easily now write to a disk in the cloud, which is made persistent. Tables is a NoSQL store which massively scales. So again, all the abstractions out here which we've spoken about, it scales because we learn from your traffic pattern and then load balance it. So tables is a very similar abstraction. It's a NoSQL key lookup NoSQL store. And some of the scenarios that it enables is, for example, maybe your website has users and you have user profiles. So you can easily store these so that when a user logs in, you can either validate, authenticate the user by storing their passwords in Azure Table or by storing their profiles in Azure Table. We also have OData protocol. So Azure Tables is basically following the OData protocol, and you have JSON or AtomPub. We recommend JSON just because of the amount of data savings it has. It's almost 75% data savings over AtomPub. But you have these two protocols that you can easily follow, use for your applications, rather. Queues is a reliable messaging system. So when you build a scalable application, your scalable architecture, there are many components that need to communicate with each other. The recommended way to make them scale is scale them independently so that one failure in one component does not back up another. So you need a messaging system when they try to communicate with each other, and Queue provides this reliable messaging system with low latency and high throughput. So you can, like I said, you can decouple your web role from your worker roles now so that they can communicate each other, and failures in one would not back up the other. People have also built asynchronous task scheduling as such. So you want to start a job in, let's say, in 2 days, you can put in a message that is visible in 2 days. Or even building process flows or workflows using these queues to kind of orchestrate the process flow. We have other additional value-add services and tools. Azure Import Export being one of those, where you can easily move terabytes of data from Azure Blobs service from your Azure Blobs service, rather, to your on-prem. So you can ship the disk, and these disks are all encrypted with BitLocker. So you can ship the disk, you can store your data, encrypt the disk with BitLocker, and then ship the disk to our data center, and we will import that data into our storage. So if you have this is very valuable, especially in places where you do not have great connectivity between your on-premise to Azure storage data centers. With respect to tools and libraries, we spoke about quite a few client libraries that we have in Java, .NET, C++, Node.js, including Windows Phone and Windows Runtime. There are PowerShell commands for many folks out there who are more used to PowerShell. They can do their more administrative workflow as such using PowerShell commands. There are CLI tools for those who are not on the Windows platform. This is all Node.js related stuff, so you can go to any platform that you work on and still kind of manage Azure storage from that particular platform. We also have a tool called AZ Copy, which enables copying of, again, data between your on-prem to storage. This assumes that you have good connectivity. In addition, AZ Copy also allows you to copy data between storage accounts. So it's kind of like a backup. So you can do that too. So AZ Copy is there for blobs today, and we will have it for tables later this year. So we spoke about Azure Storage and all its tools and libraries that are there today that enables you to communicate with it. Now getting to what kind of durability it provides, there's one durability in particular that we want to talk about out here. And again, we will double-click into the rest of the durability provided by Azure Storage in a bit. But geo-redundant storage is something where you can enable for your storage accounts. And if you have enabled it, what it does is it provides redundancy for your data across regions. And these regions are at least 100+ miles apart. It's provided for blobs, tables, and queues, basically our abstractions today that we have. You choose a primary region while creating a storage account. When you choose a primary region, the secondary region is assigned to it. So it is not user control, but these regions are kind of paired. So if you create a storage account in US West, your secondary region will be in US East. So once you have set up geo-replication, the thing to note out here, and a very common question is, how does it impact my live traffic? It does not impact your live traffic because this is done asynchronously. So it's off the critical path. We replicate your data multiple times within the same region. In addition, asynchronously, we replicate your data to a different region here. The thing that we announced at Build was general availability for RAGRS, that is read-only access to your replicated data. What this provides is a scenario for you to get higher availability if your primary region is down for whatever reason. So when you try to access your data in your primary region and you get some sort of failure, a 500 error, for example, you can now go to the secondary and read that data. Applications need to be aware that this is eventual consistency. In addition, we have provided a way for you to get the last sync time for your geo-replicated data, so you know that you're getting the data, all the data before that has been kind of committed and available to you. So that we give you a timestamp, and again, I'll show you a demo at the end, how this can help in building applications for higher availability. So how it works, you have GRS enabled. You get a secondary endpoint once your GRS is enabled as such. Or rather, once you go and opt in the portal for RAGRS. And again, I'll go to the portal and show how you can configure it. So once you enable RAGRS, you get the secondary endpoint. So now you have two endpoints. One that points to the primary, which is called account name blob table queue.co.windows.net. And then you have your secondary endpoint, which is account name -secondary. So now you have these two endpoints, and you can now choose where you want to send your request based on whether it's obviously all writes have to go to the primary, but your reads can either go to the primary or secondary. If your primary is unavailable, you can dispatch it to the secondary, basically. So applications control this, and in addition, storage client libraries have a knob for you to set this so that it automatically goes between the primary. If it fails, it'll go to the secondary. So you have a lot of these retry options out there which says primary only or secondary only or primary then secondary. So you have these options that you can set out there to choose the right location or choose the combination of location to get higher availability. The key thing to note out here is that the secret key that you get along with the account name is the same for both the endpoints. So if you get a shared access token, which is a token it's a pre-authenticated token, if you get this token, you can access your primary endpoint or the secondary endpoint with the same token. So you don't need two different tokens or you don't need two different authentication signatures as such. It just works for the primary or the secondary the way it's been designed. So yeah, again, the same storage key works. And with respect to consistency, the thing to note is we are a strongly consistent system within the primary region. If you go to the secondary, it's eventual consistency. So reading from the primary, all writes have to go to the primary, but reading from the primary is always strongly consistent. We believe that it is easier for applications to develop when we provide a strongly consistent system as such for your primary region. And so that is something which is fundamental in our layer, where we make sure that if we have given a success for your write, it means it is persistent and you can read it. And again, like I said, applications can query the service stats to get the last sync time, and based on that can decide whether it wants to go to the secondary, whether it can withstand that eventual consistency on the secondary endpoint. And also, the analytics metrics that you get on your primary is also provided on the secondary, but it's in a separate, you have separate tables as such for both of those. With respect to what's new, one of the things that we also will be announcing now is the increased scale targets for storage accounts. So each storage account was 200 terabytes. We've made it now 500 terabytes for all regions. In addition, we've increased the amount of bandwidth that you get for all storage accounts in the US region to 10 gigabits per second, even if this is in the GRS mode. So you get 10 gigabits per ingress for ingress and 20 gigabits egress for your storage accounts in the United States. We've improved some versioning on shared access signature, and I'll again go and explain that a little bit in the next slide. And from client libraries and tools perspective, we have a .NET library for the new REST version that we've announced today. In addition, you have the phone runtime support for files and the REST version 2014-02-14. We will be RTMing Java 1.0, Android CDP, C++ library is already in the CDP. We announced that just before build. And then, of course, you have AZ copy today for files, so you can, Andy's going to talk more about files. And so you can move your on-prem files into the cloud as files. And then, of course, you have PowerShell for files. And then, of course, the big feature, which is Azure Files itself. So let's get these smaller feature things away now. The shared access signature, right? So shared access signature is pre-authenticated token. So this is basically when you want to give access to your storage resources. You, as the owner of the storage account, wants to give access to your resources to a subset of folks. What you do is create a special token using your secret key, because you don't want to give your secret key. If you give the secret key off, obviously users have all access on all resources. So you want to control that, right? So shared access signature allows you to control access to a subset of resources to a subset of folks where you give the token to whomever you give the token to. And also it's time limiting, so you can control time limiting permissions. So there are various knobs out there to control on how it'll be used. There was one slight problem with the way shared access signature was previously, which is the version of the protocol was determined by the owner of the storage account who was creating this shared access signature. So the owner decides there's a parameter in your token called SV. The owner decides what version it is, and then gives the token to all the clients. Now these clients can be communicating using different set of client libraries or different REST versions as such, and they used to fail if they did not match with the storage version that the owner has decided that the token should be. So this was a major problem as such, if there was especially breaking changes in the protocol. If there were no breaking changes, things just worked. But every time there's a breaking change, we upgrade our version number. And so most folks started hitting this problem because the owner decided the version. What we provided with 2014-02-14 version is that the client who's using the shared access token has a say in the versioning. So they can apply a query parameter called API version to the URL to say, hey, no, you know what, let the SV version be the version which you authenticate with. But for the protocol, please use this version because as a client, I can only understand this version. So this now gives the control back to the clients of the SaaS tokens to kind of control what protocol version should be used by the service. In terms of shared access signature best practices, use the storage client 4.0, especially for creating the tokens. Because once you create the token, SV will be 2014. Now the clients can override the version of the protocol and things just work, especially if you're using the storage client, if your clients are using storage client libraries, it'll just work because we make sure that the storage client library makes it explicit as to what protocol version it can understand. Clients who are using their own REST implementation can always tag along this API version query parameter and just use it. Use HTTPS when transmitting SAS tokens, because whoever gets access to the SAS token gets access to your resource. It's pre-authenticated token. When resources like documents or HTML is being accessed via a shared access signature in a browser, any links that you click in that document will now expose the shared access signature to that website that you clicked on through the referrer header. So be wary about that. You can write your own JavaScript kind of blocks to either disable the shared access token or to make sure that they cannot click, or to remove the referrer header or set the referrer header to something else. And with that, there is Azure Files.
Thank you, Jay. So today we announced a new, I have to do the slides first, but a new component of our storage service. So Jay talked about blobs, tables, and queues, and today we announced files. So files is this whole new thing that's somewhat similar to blobs and disks, but it's different. So for the last few years, customers have been asking us and saying, hey, I really want to be able to put files in some location in the cloud and have VMs be able to read and write them in parallel or at the same time. Like, I want to be able to write the same file and have the other one read it, or maybe both write to it, or just have a scenario where lots of different VMs can read it. And so we've been thinking about this and working on it for a while, and decided to come up with a solution. This is what we've been telling people in the past, is here's how you do it when you have to, and we want it. So what you could do is you could set up an ISVM, you could attach a local disk to it, and then you could share that out using the SMB protocol to your other ISVMs that are running in the same VNet or in various other incarnations. There's some problems with that. One is it's limited in its scalability. Second one, it's very difficult to manage failover scenarios when that ISVM that you've shared out the disk on fails or has an upgrade or anything going on like that. Then suddenly you have to bring up another copy of that, connect to the existing data, and then also have all your clients update to talk to that new instance. So that's particularly challenging and requires people to write code and all these things. We have a blog post out there somewhere that tells how to do it, but it's rather tricky. So we've been working and thinking about how we could do this better. So what we created, building on top of the existing storage stack that we use for blobs, tables, and queues, is we created a file share. It's an SMB file share, just like you would have on premise if you took a machine and attached a bunch of disks to it and shared out its files using the SMB protocol. But now we have this platform as a service type of representation of a file share. And now I can go and connect to it from my ISVMs by just connecting through like the NetUse or right through Explorer using the UNC URL of your file share. And you're able to get the same availability, durability, scalability, and easy to manage structure that you have with blobs, tables, and queues, but you can now have it through this SMB interface. And just to make it even better, since we always expose things through REST, we also expose the file APIs through the REST protocol as well. And I'll go into that more in the next slides. So we've gone through, and I think there's lots and lots of different scenarios where you can imagine using these file shares within the cloud. We've enumerated a few of them here. So the simple one, the obvious one, is I want to have shared data across lots of VMs. And so I can create a file share, and I can allow all of my VMs to authenticate to it, and now I can read and write to it, and other VMs can see updates to that and process that data. Another one is just shared settings. So every cloud service out there has to have some place to store its settings so that when you want to make a change to the system, you can have it reflected across all of the machines that are running that. And so you can put those settings on a share. And now we even have the ability through REST to go and update those settings. So even though our file shares are only going to be available within the particular data center that they're hosted in, you can access them through REST worldwide, and you can write to them through REST. So you have some sort of XML file, and I can go and all of the VMs read from it and use that for their settings, and then I can have a REST interface come in and actually go and update that file, and all the VMs will be able to see it. And finally, we found it very useful in the last few months as we've been developing this software just to have, and testing it, just to have a file share of our own that has all of our tools and things on it like that we want to store that we use when we're manipulating VMs. And so when you want to work on a VM or debug a VM, you just connect up to your file share, and you've got all the utilities and tools and everything right there, just like, and you can just double-click on them and launch them. And I'll give that in a demo in a second. We are using the SMB2 protocol, SMB 2.1 protocol for the files service. This isn't the latest one. There's an SMB 3.0 that's out there now, but this is one that is the sort of common denominator for the majority of the operating systems that are available today. And we'll move forward as time goes forward to try to catch back up with Windows Server. Because we're using the SMB 2.1 protocol, of course, it makes it really easy to move on, or easier to move on-premise applications directly into the cloud, especially ones that are using a file share for shared data. It's a really common pattern to go put all your files on a share and have your VMs or your nodes directly contact and read from that data as part of their service. We natively support OS APIs, libraries, and tools across the board that pretty much everything you've ever used on Windows will just work with it because they're built to use the SMB 2.1 or newer protocol. So in Windows, create file, read file, write file, lock file, all of those Windows APIs that are documented on MSDN just work natively. You can also use the CRT libraries to fopen, fread, fwrite, and the newer ones, cout and cin are standard. What do they use? Yeah, I don't remember exactly what those are. The list was getting too long, so I didn't write them all down. And of course, the .NET file APIs as well, like file stream, and there's a ton of different ones of those. And Perl and anything else that just works on a file system will just work right on top of the SMB protocol that we've built with the file shares. And we support the same semantics as regular file shares. So you can rename files, move files. You can have read-only files. You can set the read-only attribute, and nobody will be able to write to it. You can use asynchronous I/O. You can do write-through files so that you're sure your data is getting committed when you want it to be. You can register for change notifications on directories. So when the directory gets changed through the SMB protocol, you'll actually have a way of querying for those changes and seeing what's changed, just like the standard Windows NTFS file system does. And there's a ton more, too. There's byte range locks, and I can't even think of all the different things that we have to support in order to support the SMB 2.1 protocol, but there's a batch of them. And, as I said earlier, so we also expose these same files out through this REST API. So it's very similar in this case to blobs. There are some differences, and I'll talk about those a little bit later. But the REST APIs allows you to access your files from anywhere on the internet, and you can read and write them. You can, as Jay mentioned earlier, you can use AZCopy to upload the files through the REST interface directly into your file share to populate it if you've got a bunch of files you want to have on there. This also allows, the REST APIs will allow you to build hybrid applications. So you can think of, you've got some sort of file share in the cloud, and you've got some VMs that are working on it. But I can also have applications running on devices or on premise that actually can use this REST interface to read and write and interface with your, indirectly interface with your applications as it's running in the cloud. And we have a bunch of APIs we support here as well. So you can, it's a fairly simple set through REST. So we can create a file, we can delete a file. I can list files in a directory, and I can sort of walk down my directory hierarchy. I can read and write those files that I've created and deleted. Well, you can't write the ones you've deleted, but or read them for that matter. And you can get the file and properties, or the properties of files, and get the properties of directories. So with that, I want to show you how this works in my exciting demo. So that's the end of the exciting demo. So what I have here is two virtual machines, two VMs running in Azure. I've set up, and I've tried to make their fonts be nice and large here. And I'm going to put one on one side, and I'm going to put the other one on the other side. Oops, I failed that question. Actually, let's do 3 VMs. Where did that other one go? Let's use a Linux VM as well. There it goes. Okay, so we'll come back to that one. So what I'm going to do on the first VM is I'm going to use like a net use command line. I don't know if you can see that. Yeah, maybe. Anyway, you can see my storage account key even. And so what we do is we use the storage account name as the username for the SMB command, or the SMB mount command, and we use the storage account key as the password, and we just do a regular old net use with the whack, and it's my account name, file demo, .file.core.windows.net, and then / my share name, in this case, demo1. And this just mounts a drive, Z, and I'm not going to do that right now. But anyway, onto that share. So I can actually go and see there's no files on there right now. Whoops, really wanted that, dir Z. Anyway, so there's no files. It's an empty 5 terabyte file share. I can put 5 terabytes of data on there. I'm going to go to this other window, and I'm going to use Explorer to mount that same share over here. And I'm going to use this cute little utility I wrote to copy my storage key to the clipboard. So I just try to connect to that same UNC path, file demo.file.core.windows.net, demo1. And it asks me for my username and password, which I happen to know. But I can't type. I'm going to paste that password in there, I hope. There it goes. And this should show up, and there should be an empty folder there, which is what you expect. So now, and this is the really exciting part, I'm going to create a file in this command shell in that file share, and the Explorer automatically registers for change notifications. So it's going to know that file appeared there, and it's going to show up on the other side. So here we go. This is the exciting part. So I echoed hello world into there, and there it is on the other side. It's so fast you didn't even notice it. Thank you. That's my magic trick of the day. We can go even further. One thing is, so I created that Linux VM as well, and I need another command line here. So mounting a share in Linux takes a giant long command line. Where'd it go? There it is. Okay. And I don't have a good font here either, but you'll just have to believe me that it's there. So I can mount that, and it mounts and says I'm done, and I can cat it. Let's see, SMB, what's the name of that? Azure Files. There it is, hello world. So you can connect to it from all different kinds of VMs.
Oh, yeah.
You forgot the other exciting part of the demo. So actually...
Yeah, I can do it later.
Actually, that's later.
That's later anyways.
Yeah,
I've taken your picture, though.
Thank you. Take my picture. I'm excited to be here. You should have taken a picture as we applauded. Oh, the tools. I knew there's another part of this. So I mentioned earlier that you can create a share for your tools as well. And so this share that I just connected to is another one that's similar. I'm mounting it on the Y drive letter in this case, but I actually created a share as well on that same account called Tools, and I can net use to that one as well. This time I didn't have to authenticate because it's in the same storage account, and Windows remembers the authentication information. But I happen to have sysinternals on a share here, and so I can double-click on that and go find procmon, and launch that. And it says, hey, do you really want to run this? It's on some file share that I don't understand, and you just say yes. And moments later, there it is. I can run a tool and see what's going on in my system right off my tools share.
We'll take the questions at the end, if you don't mind. Thanks. We have a couple more demos.
A lot of demos.
Yeah.
So I have a couple of slides in here about what I just showed because I was afraid that it wouldn't work. So That's the backup plan, but we'll just skip through the backup plan since it worked. So one of the things that's really cool about this SMB front end is we were able to take the existing storage stack where we have these sort of layers we've already built. So we have what we call a distributed replication layer that manages making sure we have all the copies of all the pieces of data that we want to store so that when one node, one disk dies, we have adequate copies of that so we can make another copy and we never lose anybody's data. And then above that, we have this massive scale-out index layer that automatically load balances across all the nodes in the system and manages all of that. And on top of that, before we had these blob table and head queues that exposed through REST the ability to read and write to the blobs and edit the tables and upsert and all those cool things you want to be able to do. And so what we did is we just glued on a new head, an SMB head. And it happens to have both the REST interface and an SMB interface. And now we get all of the scale out and all of the replication and all of the cool things that we already had built into our structure, and we just expose that through these new interfaces. We've got a link there to the SOSP paper that we published quite a few years ago now about our architecture and how we've built and designed that in order to be able to do this broad diversity of things. So I mentioned earlier that I would take some time to compare the different features that are available through Files and Blobs. And so I'll go through those now. So Jay talked a little bit about the different kinds of durability we offer. We have locally redundant storage, ZRS and GRS for blobs, and now this RA GRS, the read access from geo-redundant secondary. It's a big mouthful, but for files, we only have the two modes, the older ones, the locally redundant storage, where you have the geo replication turned off, and then we have the GRS, where you have geo redundancy on. Obviously, as we move forward, we'll be working on expanding the things that are available through the file interface. As far as access goes, I mentioned earlier many times that for files, we have both an SMB interface and a REST interface, whereas blobs just have the REST interface. Connectivity, SMB 2.1 is only available within the region. So you have a storage account in East US, then your VMs in East US can connect to it, but the ones in West US cannot see it. So that it has to be locally available there. But through REST, you can access them worldwide. So you'll be able to get to your files and update yours. So like if you had that tools share that we built, you probably would want to have that in all the regions that you're running your own VMs in order to be able to get them wherever you needed them. The endpoints look very similar for REST between blob and file. It's basically exactly the same, except you take the word blob out of the endpoint and you put in file. But then, of course, we had to add a UNC path for the REST interface. So now you have with the slashes going the other way, you have pretty much the same path, just without the HTTP. The blobs have a flat directory, a flat namespace where we did this sort of prefix thing where you can list blob names with a particular prefix, that it gives you the appearance of having directories without having actual directories. And in files, we actually have true directory objects. So you actually have to, if you want to put files into your file share, you actually have to go and create a directory ahead of time, just like you would if you were on a regular file share. Blobs are completely case sensitive, which is kind of the way that the internet works. And files is the traditional NTFS case insensitive, but case preserving. So if the first time you create a file, if you put some capital letters in it, then when you do listing later, you'll be able to see those capital letters. But you can also open the file with what they call them, small.
Lowercase.
Lowercase, there you go. An important thing is missing from my mind. In the capacity front, blobs allow you to have 500 terabyte, like one container that's a whole storage account. So you can have this huge 500 terabyte container to store a bunch of blobs in it. We've limited shares to just 5 terabytes, so they have quite a lower limit than that. So if you want the massively scale out system to allow you to have this huge global scale and everything for files, that's really a place, or for data, that's really a place where you would want to use blobs, because we've limited the space that we allow a particular file share to have. On the throughput front, a particular blob can support up to about 60 megabytes per second today, and in the file shares have the same limit for the whole entire share. So there's a throughput limit that you can achieve. on file shares today. Now, you can have more than one share, of course, and if you need more than that amount of throughput. In terms of object size, page blobs today support up to 1 terabyte per page blob, and will allow up to 1 terabyte per file. Those just match exactly. There's also a slight difference in billing as well. So blobs, we bill based on the bytes that are actually written to the blob. So if, like a page blob or a VHD, if you create a 1 terabyte VHD and just write your operating system into it, which is 18 gigabytes or something, 20 gigs, 30 gigs, I think, something in that range, you only have to pay for that 18 or 30 gigs that you actually have written to. Whereas in files, you actually have to pay for the full amount that you create. That's the content length, the actual file size. So they're not sparse. They're completely allocated. But that, in most cases, is fine. In VHDs, it's when you have sparseness, potentially. We'll move along. So we have a whole other comparison slide here for comparing Azure Files with the disks, the IaaS VM disks that we support today in Azure. So you can't boot a VM off of an Azure file share. So if you want to boot a VM, you'll have to, the OS disk for your VMs have to be within the blob system in order to be able to boot off them. One of the sort of nice things in some ways about the disks is that they are dedicated to a particular VM when they're mounted on it. So you don't have to worry about people corrupting files or both trying to write to the same file at the same time. But then again, you can't share them. So that's where shares come in. You can actually share a share between many different VMs and allow them to read and write at the same time. But you do have to worry then about the ability for them to both write to it at the same time and make sure that your program knows how to handle that. Many programs do, and there's things built into the SMP protocol, locking at the byte level to allow them to coordinate that. So some applications, some libraries will know how to do that already. We support snapshots and copies within the file system, but we don't, within the blob system, but we don't through the files today. So if you want to take a snapshot of your data, you have to be within the blob space. Configuration and authentication. And one of the nice things about IaaS VMs is that you specify that you want to mount this disk to this VM, and all the authentication, everything is all handled in the background, and it's done actually outside of the VM. So the VM just thinks it has a disk as it's booting up, and it knows that it can read and write to that disk. Whereas with shares and files, you actually have to authenticate afterward before you can use it. So you have to somehow store your storage account key into your VM state in order to be able to mount that share. Whereas in the disk case, it's all authentic or automatic for you. Cleanup is one of these either-or things. So they've built in the IaaS VM space, they've built the ability to, when you delete a VM, to delete the disks associated with it. Sometimes people do that when they don't want to do that, but it's a good thing because if you have lots of VMs, you can then manage your VMs and disks together. Whereas with file shares, you have to manage them independently because the file shares are sort of totally disjoint from the disks. So it's a good and a bad. We talked about the maximum size a little bit on the last slide, but so a disk can be up to 1 terabyte today, and you can mount the largest VM size. I think you can mount 16 disks to it. In the file share case, you are limited to 5 terabytes per file share, 1 terabyte file each, as we said earlier. But you can actually connect to a lot more file shares from a VM than you can mount disks. So I don't even know what the limit is. I tried to find it. I didn't try to find it by calling netuse a lot of times, which is one way to find it. But I tried to find documentation on that, and there doesn't seem to be a limit. I would imagine it's a memory limit that you'll start to get. If you mount too many of them, eventually you'll run low on memory. We also have an IOP throttle on disks. So we limit disks today to 500 IOPS, so that for a variety of reasons. And we have a similar IOPS throttle on shares that it's going to be 1,000 IOPS. So that can be spread across multiple files on that share. And of course, you can mount multiple shares to work through that, just like you can mount multiple disks on an IaaS VM to get through that. And I mentioned as well, the throughput on a disk is the same as the throughput on a blob at about 60 megabytes per second. And we have the same limit on shares as about 60 megabytes per second. That's client OS support. So I demonstrated Server 2012 R2 and one of probably the latest Ubuntu version. So the Windows SMB 2.1 protocol has been supported since Server 2008 R2, and so you can, and anything forward from that is compatible with it. On the Linux side, it's I forget the exact wording on the Linux is a little bit unclear, but it's not, SMB 2.1 isn't completely supported, but it's somewhat supported, and you have to, some distributions have it working and some don't, and you have to kind of find the right one there. But hopefully that will continue marching forward. They've been working on SMB 2.x for a while and 3.x as well. Oh, and getting started. So how do we get to use Azure Files? Yeah, I'm also excited. So right now, I believe it's working as of now on the portal. You can actually go in there and then one of the preview options and say, hey, I want to preview Azure Files. And you can click and you'll request a token and we add you to a queue. And then as we're going to grant these in batches by the end of this month, we're going to start to grant these and allow people into the service to try it out. And once you do get your token, you can redeem it. At that point, you have to create a brand new fresh storage account, and that will have the endpoint provisioned, the file.core.windows.net endpoint. So old storage accounts won't have that for now. And then you got to create a share. So there's a couple of different ways. The easiest one is probably PowerShell. So you have to go download our PowerShell commandlets, and there's some documentation on our blog about how to do that. And then you got to get files in there probably somehow. So there's a couple different ways you can do that. Also document on the blog. The AZ copy is one of them. There's a command line on how to do that. The other one that I use all the time is I just mount the share in a VM and I just paste it into my share. You write it through Explorer, through RDP protocol. And then you got to connect to it like I did in the demo as well. So another demo. Where's the next slide? So this demo, Jay put together, or we both put together pieces of this one. So what we did is we set up two Azure VMs, and they were both running IIS, but we took the directory that they serve their content out of, and we replaced that with our file share. So these two VMs are both pointing at the same backend file share. And then Jay put you have a PowerShell script that's sitting there, and we created kind of an incoming directory. And so his little fab, what do you call it? I keep kind of calling it a fabulet, but it's not.
No, this is the Android device that we have out here. So we have an application sitting out here which can take a picture and then upload it to this file share using the REST API. And of course, Andy has a Windows phone.
And I can't find where'd my VM go?
Oh,
I'm in my VM.
This is the file share demo VM.
That's the wrong VM.
Yeah.
I wanted my VM because it has the window to the incoming directory. Here we go. There it is. So I close this, and then I push 4. Yeah, so there's his file, the same way I showed earlier that there's a file share with the file.
Yeah,
when he took the picture using that tablet, it automatically uploaded it to this directory, and then he's got you want to switch over?
Yeah, so that file disappeared, and I'll let you know why it disappeared. That is intended. There you go. Oh, sorry. I need to get to this guy. By the way, this is a blog site, and it has a new blog on the file service, which is a good read and covers in details as how you can start using it. But anyways, what we have here is the same image directory that Andy just shared on his other VM, is this particular one. And Andy just took a picture from... That's nice. Yeah. So Andy just took a picture out there before he ran away from that noise. Using his Windows phone, and that's uploaded out here. Azure Files is like steroids to virtual machines. By that I mean I haven't used anything Azure storage specific out here once I've mapped that network drive. The ASP.NET web application that this runs and the PowerShell script that Andy mentioned, which looks for change events in this particular image directory that you see at the bottom. As images get into that, the PowerShell script is running in the background. It looks for the change notification, and actually, let me show that here. Look at these change notifications. So it's receiving these change notifications. What it does is it uses a third-party thumbnail generator. It doesn't have any storage-specific stuff. It's looking for change notification and then executes executes this process for generating thumbnail and then storing it into this other folder out here that I have, which I call it as file share demo bin images. So all the images go to that. So now when I can access this website, all the pictures start to upload into this, and any new picture will show up out here. So again, phones use REST APIs, put it to the file share. I have a PowerShell script, which I'll just show you in a bit, which is looking for change notifications. When a file is created, generates a thumbnail using a third-party software, and then copies that thumbnail back into this ASP.NET Web Application share that I have called images. And just to go through this particular guy. So if you see the PowerShell script out here, there's nothing storage specific. It's looking for a change notification event. Out here, it's registered for a change notification. When it receives this change notification, all I do is I execute this thumbnail generator on it, and then copy it and tell that process to create the thumbnail in my ASP.NET Web Application. And once again, we will document all of this in our blog. This website itself is called File Demo, right? So if you look at the bindings, it is called File Share Demo that I kind of looked at through the web browser. But if you look at the basic settings of this is actually using the File Share Demo, IS Demo File Share Demo bin folder. So it's pointing, all my ASP.NET Web Application has been published to this share, and I'm running my website off the share with both the VMs actually pointing to it. So once again, let's go back here. Look at this. It's been served from JDemo 2. If I get lucky, it might be served from the other demo, my other box too. Yeah. So there are two machines out there sitting in front of the load balancer, sitting behind the load balancer rather. As request comes in, it directs this, it goes, it runs it's ASP.NET is hooked up to IIS, and now it goes and looks at all the images, and then you see those images out here. So this is where the ASP.NET Web Application didn't have to know anything about storage. It was just looking at local directories. The PowerShell didn't have to know anything about Azure storage. It was just using scripts. So all of it was just non-Azure storage specific, and all I had to do was map that Azure file share to my virtual machines. And so that was the demo with respect to this particular Azure Files. Going back to the PowerPoint. And once again, these were our backups in case it didn't work. So let's get to what's coming. There are more client libraries in terms of Node.js supporting our latest REST protocol. That would be in CDP in the next couple of months. We will be having an iOS library in CDP by end of this year so that you can now develop even applications for your iOS devices. JavaScript library so that now you can use cores that we support for your web applications as such. In addition, there's a new durability offering called Zone Redundant Storage for block blobs that we will be releasing in the next few months. So to get into this durability that I said, I'll explain more into what it means. There are three types of durability. LRS, which is local redundant storage. It stores 3 replicas of the data within the same within a single zone within a region. So all your 3 replicas are within one zone within the same region, and because of the 3 replicas, or rather the 3 replicas that we store within the same zone, it can provide durability despite let's say, node failure or rack failures or disk failures, right? Then we have zone redundant storage. It's available only for block blobs, and it stores these 3 replicas of your data across multiple zones, and it is designed such that it would be all in the same region, right? It'll be within the same single region, but in certain cases it may span regions as such, but it's designed to be within the same region. And it provides additional durability than LRS because now it is 3 replicas within the same region, but different zones, right? So you get durability against basically zone-related failures, like fire in a facility and things like that. Each zone is its own independent thing. So fires in a facility or a fire in a zone can be protected against. And then, of course, you have the GRS capability, which is we store 6 replicas, 3 in the primary region, 3 in the secondary region. So it's across 2 regions which are 100+ miles apart. And what this provides is really the best kind of durability, and it protects you against region-wide failures, catastrophic failures like earthquakes, tornado, and things like that. So it provides you against regional failure. It provides safety against regional failures. In terms of pricing, and this again you can get it from the pricing chart, but I wanted to highlight a couple of things. ZRS from Azure Storage compares very well with Amazon S3's standard redundancy, and LRS compares very well with reduced redundancy. Remember, LRS is 3 replicas though, and ZRS is again 3 replicas in different zones within a single region. What we have provided in addition to that is GRS, which is across 2 regions. So it's 6 replicas, but note that it is not twice expensive as ZRS as such. ZRS is 3 replicas, and GRS is 6 replicas across regions. And then, if you have GRS turned on, you have RAGRS, which I have a demo again to kind of go over it. So you have RAGRS, which provides you higher availability for your application. So especially enterprise applications that strive for higher availability can use RAGRS to achieve that. So let's go over some of the patterns of scalable and resilient for building scalable and resilient applications. And these patterns are something that we've learned working with other teams within Microsoft, and even sometimes external teams that we cannot mention, external companies that we cannot mention out here. But we've worked very closely with these, and we come up with patterns, and we've documented a few patterns that have come up over and over again. And so let's start with the first one, which is pattern for pre-processing resources. So, for example, you want to upload an image to a blob. And then whenever an image is uploaded, you want to do some encoding on that blob and image, and then make it available, right? A normal tendency to do this is just keep listing your blobs in your namespace for newer blobs. That does not scale, especially in a high-scale scenario where you have to deal with millions of images. Scanning or listing is an expensive operation. It might work in your prototype, but it wouldn't work once you publish your application. So most of the services, what they do actually is when a device uploads an image, it also puts a message in the queue with the URI saying, hey, I'm uploading this message, so please, when you process this message, look for this image, and then process that image. So what it does is the device puts a queue message, uploads the blob, and when the worker role gets it, if the blob has not been uploaded yet, if it hasn't finished uploading, it would wait for a certain timeout period. But if it exists, it is going to create a thumbnail, put it in the right location, and then delete this temporary location to say that, yes, it has been completely processed. So this is a much higher scale pattern to use than listing blobs for something that common. The second pattern that we wanted to cover is how do you scale beyond a single storage account? There are multiple reasons why you might need multiple storage accounts. Of course, one being proximity to your customers, because they might be worldwide. The second most common is that you have increased the amount of data store that can be stored. Now it's 500 terabytes, but you might have increased that storage space or its bandwidth, ingress, egress, or its TPS, which is how many transactions a storage account allows, which is 20,000 per storage account. So if you have exceeded that, you might start creating multiple storage accounts. When you build an application and your vision for that application is that needs to scale very well, if you have those goals, one of the things that you need to do is build your application such that it can expect multiple storage accounts. And the way to do that would be you create how many ever storage accounts that you need today, and then have a lookup map. And this is a pattern. The semantics are very similar to what OneDrive uses, which is keep a lookup table, which looks up from a username of my application to a virtual bucket ID that I keep creating for each user, mapped to a storage account. The reason I've not just mapped a username to a storage account is what if that user actually exceeds the storage limit of a single storage account? Or what if the user becomes really popular and has more TPS than what was intended? So I want to make sure that I can scale out a single user for my application, and also I can keep adding newer users. So I've maintained this virtual bucket. And then in the storage, in Azure Storage, what you do is you use that account name, maybe a fixed container name, and then my user account name as a virtual directory, and then all his resources in there. And I store that link, which is saying, if my user comes with username X and bucket ID 1, this is the storage account name that I need to use. And this is where I can find his resources. So OneDrive would use the URLs under user resource with the users, but with storage, it will use the storage resource looking up at this lookup table. And this lookup table is pretty small, right? Even if you have 1 million users, you can keep this lookup table in your memory and still serve it. So you can cache this stuff, so you're not doing disk IOs every time you want to look up the lookup table. And it's rarely changing, so you can cache it for a longer time. And if a user exceeds, I can create a new bucket ID and change the account name that he has to be mapped to. Or if I have a new user, I can, again, map him to a newer storage account if I have exceeded my quota for my existing storage accounts. So I can keep growing my application without having to create all the storage accounts I might need upfront. So I keep creating the storage accounts as my users tend to scale or as my application tends to scale. The other one is pattern for higher read availability and consistent low latency for web requests. And this is a very familiar pattern for Xbox especially. Xbox wanted to make sure that their service is up and running, even with interim, let's say, errors from the storage service. So they wanted to make sure that their application starts running. So what they did was they used these table queries for tracking game states. And their web service actually maintains a cache for the game state. And whenever they get a request, they look up their cache. If it's a cache miss, they go to Azure Storage. If Azure Storage fails for whatever reason, they fail fast and return a failure to the user, but in the background, they keep continuing to try Azure Storage. And if the primary region is down, they don't mind going eventual consistency. They go to the secondary region, get that data, and serve it. In their scenario, serving that stale data is a lot better than failing that request and the user not being able to play on his Xbox, which is kind of obvious once you think in terms of playing a game on Xbox, right? So this is what they've done, and this allowed them to get higher availability for their reads despite failures, interim failures on their primary account, or primary region, rather. And so back to a demo for read from secondary. So what I have here is I'm running it on localhost just because I want to show some fiddler traces as to how the client library is actually going to the secondary to read it. So I'm going to just run it on my local host, but it's also deployed on a virtual machine, and it works out there. So this is a micro-blogging site where you can select one of the sessions and just post a message, right? And so and when I hit refresh, it gets all the messages that that has been written. I have impersonated Andy out here asking questions, but if I need to ask more questions, I can go here. And remember, all the writes need to go to the primary location. By the way, to simulate failures, what I've done is I've put a firewall rule to block that IP address, which is my table endpoint, right? But that rule is disabled right now because I need to write. But this is where I can go and post a new message. And remember I said you can go to the secondary region and ask for your service stats, which gives you a last sync time and a status for your geo-replication. When I go to about, it says the secondary replication status is live, and the last sync time is what I received from it. So it's in UTC time, so it's 9:02:26, which is about 3 minutes lag between my primary and my secondary. So when I go there, and let me impersonate, no. I'm just going to submit this. You see this on the primary, right? Now let me go and enable this rule. If I refresh, and let me go here, and don't need these. So if you look at it, it went to the primary. Oops. Just 1 minute. Yeah. So it goes to the primary. It does not find, it returns 502, so it goes to the secondary. Let me just clear this to make sure it is happening that way. So yeah, here you see again. So it goes to the primary, returns a 502, and then it gets everything from the secondary. And this is what you see out here. So it's replicated, and if I go to about, it's moved forward to 904 now. So it's got that new transaction that I just posted from my secondary. So I could now serve the same message from my primary, or rather, I tried to get it from primary, it failed, and then it went to the secondary. To go through the source code out here, and all the storage keys that we provided will be regenerated by the end of this demo. So yeah, that was intentional. So if you look at this, index is what the action that by the way, I'm not an ASP.NET guy, and I literally had to learn ASP.NET on my flight out here from Seattle to Houston. So thanks, United, for giving me internet access on the flight. But this is what the index action looks like. So when you go to the home page, index gets called, and the session that I've selected, and what it does is it creates a table reference. It creates a query which says, hey, for this session, get me all my top messages, top 5 messages basically. And then when I execute, I call it with primary, then secondary. So what happens now is it goes to primary, it fails, and then it goes to the secondary location. Just with this one little thing of request options, it goes from primary to secondary on a failure of 502. So I didn't have to do much out here to get that going, to get higher availability from read from secondary. My storage client library just did the magic for me. All the writes, however, still needs to go to the primary, and add messages where all the writes happen. When I execute that operation, I don't give it that option of secondary location because all writes will fail out there. And this is where I can show you. I still have the firewall rule enabled out here, this firewall rule. And if I go to my fiddler, yeah, it's going to try 3 times or 4 times and then going to fail. It's not going to take me back to my home page. So all the writes are failing out here because it doesn't go to the secondary. Secondary cannot take writes for obvious reasons. It's a read-only access to the secondary, and this call is going to fail out here. So yes, you get higher availability for your reads and not necessary writes. So one of the ways some application do is, especially if they have a pen pattern kind of thing, where they can create a new storage account and start writing to it, or a different storage account. They keep different storage accounts for writes. Maybe the lookup table, they can go and say, hey, I'm going to write actually to this other region now. Like OneDrive can always do that, right? Because for their account, they can now create a new bucket ID, give it to a different storage account, the writes continue, and for reads, they can always go to the secondary and still serve it. So that lookup table actually came in handy to provide an architecture that scales even for my writes, or rather architecture that provides me higher availability and scalability for writes and reads. So that's something which you can always use. So that was the demo for read from secondary. So just to summarize, Azure Storage, it's durable, scalable, highly available cloud storage system. And we use range-based partitioning schemes so that it will auto-load balances to meet your scale needs. We've introduced Azure Files, which is basically a file share in the cloud. So now it's a PaaS service which you can use in your Azure VMs to share this data across different VM instances. Remember, a disk can be only attached to one VM, whereas an Azure share can be now shared across multiple VMs. If you look at our demo, in fact, all the tools we needed to set some configurations in multiple VMs. We just put it on the share, and now we could just execute off the share. And so it's very easy. It's literally what I was telling Andy before is it's like steroids for Azure VMs, because now I don't have to copy paste these tools multiple times into each Azure VM that I need to deal with in a given region. We also spoke about different durability options, LRS, ZRS, and GRS. And of course, RAGRS for higher read availability for applications, so that now you can read from your secondary region and to note that it is eventually consistent. Client libraries provide this functionality out of the box. You saw that code. I just needed one line in my request options to say the location mode is primary, then secondary, and it did the magic for me. You can write your custom policies too, retry policies if you need to, get something real fancy in there. Details on our internals, if you're really wondering how we did all the load balancing or the distributed file system and how all of it has been put together, refer to the SOSP paper out here. It was written in 2011, but it's still true. This is a slide where different services or different software, you can resources to learn more about it. And again, more resources where you can get more information. And the other thing that I wanted to add is you can always go to our blog website. So if you just search for Windows Azure Storage Team, or rather, actually, forget the Windows part. It might still be there, though. Azure Storage Team blog. If you Bing or use your favorite search engine, whatever it may be, you should get a link to our blog site, and you should be able to get to our blogs from there. We have a series of blogs over the next few days. We have the Azure Files out there with more information, exactly like how do you work with PowerShell and things like that. So a lot of information out there. Do go to our blog website. In addition, we have quite a few engineers out here in the booth and in the stock out here who will all be available in the booth. Look for us under Developer, Platform, and Tools. I haven't been to the booth yet, but I will be because both of us are scheduled to do some booth duty today starting at 5 o'clock. So please do stop by. If you have more questions, we can take it out there. We can sit and talk about the applications that you want to build, whether it's a good idea, bad idea, what you can do, what are your options, all that stuff. Our PMs, our devs, engineers, everybody can sit and kind of brainstorm out there. You can also meet us at Ask the Experts and meet in Geek on Tuesday, 6:30. And yeah, please do stop by. We look forward to meeting you all. In addition, if you're using Azure Storage today and you have feedback for us, we have a session that is set up at the Hilton. So there's a bridge that just takes you to that hotel. You don't even have to leave the building. So do meet us. This is on Tuesday. This is tomorrow at 4 p.m. to 5:30 p.m. And it's room number 327. So do stop by, and we will definitely love to get your feedback on it. And please complete the evaluation forms. You can win Xbox Kinect gift cards, all nice things. I'm going to fill my own evaluation at the end. Yeah, and this is the code for evaluating a session, so please do so. It'll be really beneficial for us if you can get that going. I think we are out of time, unfortunately. It shows I'm 5 minutes overboard. So we will stand here until the next speaker comes in. We will take questions out here. Yeah, let's meet even at the booth if you just cannot get to us today.